Good morning, everyone. Thank you for joining us. I'm Steve.
And I'm Scott.
And together we are Backyard Musings in the Backyard, People's Republic of California.
And we're just having a little conversation before the conversation about this article. So here we go.
Yeah, to continue our Antarctica theme from yesterday, in a record-breaking event, Antarctica's Hektoria Glacier lost nearly half its mass in just 2 months. Do you have any comments about that?
Well, I don't buy that. I just don't.
So it was filmed in a glacier?
Is it a glacier or is it an iceberg? I guess it's a glacier until it breaks off and then it becomes an iceberg.
Right. If it's big enough to be, yeah.
So glaciers. I
It
was just
recorded
up in
in
the
a
High Sierra
soundstage.
just a few days ago, and there's 2 glaciers up there, and they've been there for thousands of years probably, and they never change. And it gets hot, it gets cold, hot for a long time. Right now we've been talking about it. We're in an extended Indian summer for California, Southern California. Mm-hmm. Temperatures would normally be in the 50s for highs, and we're having 70s for highs. So this is very unusual. But anyway, we'll get into it. I don't know anything about this.
He doesn't believe it.
He
thinks it's a hoax.
I think it's just natural. It just happens, and then there's
2 months,
be a freeze.
Half of its mass.
Yeah, I don't know.
So if somebody told you half of the mass was gone, you wouldn't believe them until you saw it yourself.
I would not.
Sierras.
I would not. Yeah.
Okay. A glacier. I'm doubting Scott. A glacier on the eastern side of Antarctica has undergone the fastest retreat ever documented in modern times. In only 2 months, nearly half of the ice vanished, according to a new study led by the University of Colorado Boulder and published in Nature Geoscience. The Hektoria Glacier lost about 8 kilometers, 5 miles of ice in early 2023. Researchers found that the glacier's collapse was driven by its unusually flat bedrock, which allowed it to start floating once it thinned significantly. This shift set off a rapid and uncommon calving event that caused the glacier to break apart into
icebergs.
Yeah. Would you like to know more?
And then when icebergs get out they get out into the ocean, then they melt, right? Because eventually, the water is less than 32 degrees or whatever the freezing temperature is.
32.
Greater than 32.
Yeah, eventually it'll melt.
Yeah, so so the discovery offers scientists a new way to pinpoint glaciers that may be at risk of similar rapid retreats. Although Hektoria Glacier covers about just 115 square miles, which they say is about the size of Philadelphia.
He doesn't believe it.
Well, it may be the size of Philadelphia. That I don't know. I've never been to Philadelphia, but anyway, experts warn that comparable events on larger Antarctic glaciers could have severe consequences for global sea level rise. So here we go. If you own beachfront property, you have to raise your seawall whatever.
What would happen if all the ice and snow on this earth melted? What would happen?
Well, a lot of it would...
Talk to me.
A lot of it, I think, would be... Evaporate into the atmosphere and become like storms and rain.
Overnight?
And then it would refreeze and... well, not overnight, but, it would take a while for all that to happen, right?
No, I'm just saying, what if it happened all at once right now?
Like within an hour or minutes?
Yeah, it all melted. The water would rise up. The water level would rise up.
We would have, lakes would be full. Pockets of low areas.
The coast would be gone.
Dry lakes would be full again. I don't think all the water is going to flow into the ocean, right? It doesn't all flow into the ocean.
Well, we're talking
we would
Antarctic,
have to consume it.
Arctic.
We would have to consume some of it. We could bottle some of it. We could put it in containers and stick it on the shelf.
Scott, denial is a river in
Egypt. I know that. I'm not in denial. I know the process of water. I paid attention to that in science class, but I just don't. And what are you saying? Then the bigger, what's going to cause that?
No,
is our Earth going to shift closer to the sun?
Harry Potter's wand would do that. What I'm saying is, if all the ice melted, undoubtedly the water level will go up. So, saying this is not unreasonable to say that this glacier could calve off and go into the ocean.
Okay, so the water that would be created into the ocean would be the North Pole, South Pole, right?
Well, what? Yeah, or Himalayas, wherever you have snow.
But that water's got a long way to go before
Sure
it gets
it
to the
does.
ocean.
Yeah, it'll
So
fill
it's
up
going to
lakes
find lakes and areas that are low are going to be like Death Valley, for instance. That's a very low area.
Yeah.
That would be. There's no ice near Death Valley, but that water. Again, define the ice. There's not snow like right now, like I just mentioned. Eastern Sierra, this time of year, they usually like to have some kind of a snowpack for skiing and that kind of stuff, and to replenish the lakes. But it's not there. I mean, there's snow in the mountains, but it's just not like it would normally be. So if all that snow were to melt, it's going to just overflow the lakes. The lakes are going to overflow into the streams and rivers, and then erosion, depending on where the water goes. Excuse me. But you're talking a catastrophe, right? You think it's catastrophe?
No, well, I'm just saying,
catastrophic.
Undoubtedly, the water would rise. I don't know how much, but if the water rose, then you're going to have coastal areas that will get wiped out. The new coast would move inland until the water evaporated and over time, and receded. Then we could claim back those coastal areas maybe to where it went, but it's going to rise. The water's going to rise, man.
You heard it here first, folks.
Quote, when we flew over Hektoria in early 2024, I couldn't believe the vastness of the area that had collapsed, said Naomi Ochwat, lead author and CIRES postdoctoral researcher. I had seen the fjord and notable mountain features in the satellite images, but being there in person filled me with astonishment at what had happened.
Good astonishment, bad astonishment. We don't know, I guess.
We don't know.
The research team, which included CIRES senior research scientist Ted Scambos, had been studying the region around Hektoria Glacier using satellite imagery and remote sensing for an unrelated project. Their goal was
for Bigfoot.
Yeah. Okay. Their goal was to investigate why sea ice had detached from a glacier or nearby glacier roughly 10 years after an ice shelf collapse in 2002. During this analysis, lead author Naomi Ochwat discovered surprising data showing that Hektoria had almost completely vanished within just 2 months. I say, yeah, somebody's passing on some bogus information.
This was Scott says it's filmed in a soundstage somewhere.
Yep, soundstage in Van Nuys. Yep, where y'all think that the Apollo moon landing was filmed, but.
Determined to find out what caused such an abrupt change, well, Scott already knows, she began a new investigation to uncover why the glacier retreated so rapidly. Many glaciers in Antarctica are tidewater glaciers that rest on the seabed and end with their ice front in the ocean and calve icebergs. The topography beneath these glaciers is often varied. They may sit upon deep canyons, underground mountains, or big flat plains. In Hektoria's case, the glacier rested on top of an ice plain, a flat area of bedrock below sea level. Researchers previously found that 15,000 to 19,000 years ago, Antarctic glaciers with ice plains retreated hundreds of meters per day, and this helped the team better understand Hektoria's rapid retreat.
When tidewater glaciers meet the ocean, they can go afloat. That would become iceberg, right? Mm-hmm. Where they float on the ocean surface rather than resting on solid ground. The point at which a glacier goes afloat is called the grounding line. Using several types of satellite data, the researchers discovered Hektoria had multiple grounding lines, which can indicate a glacier with an ice plain topography underneath.
Hektoria's ice plain caused a large part of the glacier to go afloat suddenly, causing it to calve quickly. Going afloat exposed it to ocean forces that opened up crevasses from the bottom of the glacier, eventually meeting crevasses exposed from the top. That makes sense, causing the entire glacier to calve and break away.
The team used satellite data to study the glacier at different time intervals and created a robust picture of the glacier, its topography, and its retreat. Quote, if we only had one image every 3 months, we might not be able to tell you that the glacier lost 2.5 kilometers in just 2 days. This is according to Dr. Ochwat. Combining these different satellites, we can fill the time gaps and confirm how quickly the glacier lost ice.
The research also used seismic instruments to identify the same ones that to find Bigfoot, to identify a series of glacier earthquakes at Hektoria that occurred simultaneously with the rapid retreat period. The earthquakes confirmed the glacier was grounded on bedrock rather than floating, proving both the presence of an ice plain topography and that the ice loss contributed directly to global sea level rise. Right there. Ice plain topographies have been detected across numerous glaciers in Antarctica, and the research on Hektoria will help scientists anticipate and forecast potential rapid retreat across the continent.
Quote again, Hektoria's retreat is a bit of a shock. This kind of lightning fast retreat really changes what's possible for other larger glaciers on the continent, according to Scambos. If the same conditions set up in some of the other areas, it could greatly speed up sea level rise from the continent. Here we go.
Let's hope that doesn't happen.
Yeah, so
don't want that to happen.
Yeah, I don't know. I just, again, that 2 months, that just doesn't seem possible to me. But
we're not
I'm
the
just
experts.
a simple guy that thinks in simple terms and simple ways. So anyway,
thank you, folks. We'll catch you in the afternoon.
It's all up to you. You decide.
The
All
truth
we
is
do
out
is
there.
provide the information. Have a great